Hello everybody, this is Esther here. Welcome to my channel. Today we're going to be starting exercise 8.1 question number 4. So let's get going. So this is the question which you can see right here on your screen that says that show that the diagonals of a square are equal and bisect each other at right angles. So we all know that a square looks something like this, right? So diagonals of a square. So what are diagonals in the first place? Do we all know that? So diagonals are nothing but the line segments joining the opposite sides of opposite vertices, basically, okay, of any quadrilateral or any polygon, etc. So now let's say A, B, C, D is a square. Now the diagonals of the square are AC and what? BD. Okay, so what do we have to show? Let me just write that down for you. So prove or show that the diagonals of a square are equal and bisect each other at right angles. So that means AC is equal to BD, we first must say. Then we also need to say that, let's say the AC and BD meet at point O, then we need to say that AO is equal to CO and BO is equal to OD. And last but not the least, we have to say that they bisect each other at right angles, meaning this angle is a right angle. We have to prove that. So angle AOB, let's say, is equal to 90 degrees. You just have to prove that one of the angles is 90 degrees. You can take angle AOB is equal to 90 degrees if you want to prove that, or angle BOC or angle DOC or angle AOD, all these are equal to 90 degrees. Any one of these you can take and prove, right? Because if you prove one angle to be 90 degrees, that itself is sufficient. Clear? So let's first prove that the diagonals are equal to each other. So let's get started. So proof. For proof, we are going to consider first two triangles ABC and DCB. Let me just try to highlight that for you. Okay, the highlighting is kind of not working, so it's okay. But point here is triangle DCB and ABC. Please look at the figure. DBC, ABC. These two triangles we are considering, and we're going to prove that these are congruent to each other. Okay, so let's see how to do that. So in triangles ABC and DBC, can you tell me what are the things that are equal? First, I can say BC is equal to CB because, well, it is a common side, right? Common side. Please look at the figure when I'm talking about, sides, angles, etc., right? So BC is equal to CB. This is the common side. Then what else can we say? We can say that angle ABC is equal to angle DCB, because we know that the angles of the square are 90 degrees, right? So then also I can say that AB is equal to DC. Why? Because sides of a square are equal to each other, right? Sides of square are equal to each other. So which congruency rule am I using? I'm using SAS, right? SAS. So by SAS, I can say that triangle ABC is congruent to triangle DCB. Clear? So now I said that these two are congruent to each other. Now why did I prove that they are congruent? Because by CPCT I can say that what? AC is equal to DB. So first part of the question we have proved that it is done. Okay, so we have proved the first part of the question. Now second part of the question, what is it? We need to prove that AO is equal to CO and BO is equal to OD. right? So for that, which two triangles we can take? In triangles AOB and COD. Look at the figure. AOB and COD. These two triangles we're taking. Okay. So in triangles AOB and COD, can you tell me what are the things that are common? First, I can see AB is equal to CD once again because sides of square are equal, right? Then I can also say that angle AOP is equal to angle DOC because they're vertically opposite angles. And I can also say that angle ABO is equal to angle CDO. Why? Because of alternate interior angles. Understood? Let me just point all of these points onto the figure. Which ink do I use? Yeah, okay, I'll use this ink. Now AB is equal to CD. I said AB is equal to CD. Please look at the figure. Angle AOB is equal to angle COD, and angle ABO, this angle, is equal to angle CDO, this angle. So which congruency rule am I using? I'm using what am I using? I'm using AAS, exactly. So by AAS, I can say that triangle AOB is congruent to triangle COD. And now I'll just write the next part of the proof here. Now I prove that these two are congruent to each other. Now by CPCT, what can I say? By CPCT, I can say that AO is equal to CO and BO is equal to OD, right? So now I proved the second part of the question also. Clear? So I hope you understood how we did this. Now I'm just going to redraw this square figure again because it's kind of shabby. A, B, C, D. Okay, so now we prove the first and second part of the question. Last part of the question is angle AOB is equal to 90 degrees. We have to prove. That's all. Okay. Now we are going to take again two triangles. In triangles AOB and COB. Okay. AOB and COB. These two triangles we're taking. Now, what are equal in these triangles? First, we can say that AO is equal to CO. We just proved by CPCT here. We proved it's equal. So you can say proved in the brackets. AO is equal to CO. I can say AB is also equal to CB. AB is equal to CB because sides of square, and also BO is equal to OB. Why? Because they are common, right? Common to both the triangles. Did you understand how I said these three were equal? Let me just again show to you by using another ink here. Now I said that AO is equal to OC because we just proved it here, right? We proved it here. Then also AB is equal to CB. Why? Because sides of the square are equal to each other, right? And also I said BO is equal to OB because they're common, isn't it? So that's how I said that these three are equal to each other. Clear? Now I can say therefore that triangle AOB is congruent to triangle COB by which congruency rule? Side, because all three are sides only, right? So by SSS, I can say that triangle AOB is congruent to triangle COP. Clear? Now, therefore, I can say that angle AOB is equal to angle COB. 1 second. By CPCT, I can say angle AOB is equal to angle COP, isn't it? And I can also say that what angle AOB plus angle COB is equal to what? If I add these two, what will I get? I'll get exactly 180 degrees, because why? These two are linear pair. Look at the figure. These two are linear pair, right? So they will sum up to 180 degrees. You can write linear pair in brackets. Clear? Now angle AOB plus angle COB is equal to 180 degrees. Now since angle AOB is equal to angle COB, can I say that thereby, sorry, I can say thereby that 2 angle AOB is equal to 180 degrees. See, since angle AOB is equal to angle COB, so angle AOB plus angle AOB will be equal to 180 degrees, right? Because instead of angle COB, I've written here angle AOB in this equation. Clear? So that's how I got 2 angle AOB. I hope you got it, right? So 2 angle AOB is equal to 180 degrees. Angle AOB is equal to 180 by 2, which will give you 90 degrees, right? When you divide and check. So therefore, angle AOB is equal to 90 degrees. So we proved the third part of the question also. So this is how we do the fourth question of exercise 8.1. I hope you guys understood it. Thank you so much for watching this video. If you found this video helpful, please make sure to like, share and subscribe. And if you have any comments or any doubts, please make sure to use the comment section down below for that purpose. And make sure to check out my channel for more such fun videos and many other types of content as well. Okay, then till I meet you in the next video, take care of yourselves and bye bye.